In this video, we're going to be looking at combining two functions using the four operations: addition, subtraction, multiplication, and division. We're going to do those separately. So we have an example for each type of combination. In A, we have f of x is equal to 2x plus 1, and g of x is equal to x squared plus 2x minus 1. Find parenthesis f plus g parenthesis of x. Then evaluate the new function when x is equal to 3. So this notation right here is the same as saying find f of x plus g of x. So what we're going to do is I like to use the notation that I just wrote there. And I'm just going to substitute 2x plus 1 in for f of x and x squared plus 2x minus 1 for g of x. Notice I substituted in parentheses. And now I'm just adding these two functions together, so I actually don't even need the parentheses. I'm just going to drop them. And now I'm just going to combine like terms. So we have an x squared, we have 2x plus 2x, that gives us 4x. And then we have 1 minus 1, those just cancel out. And we're left with the function x squared plus 4x. So now it asks us to evaluate this new function. So let's go ahead and evaluate this. So we know well, let's write this notation. So f plus g of 3. So now we're going to take that function that we just found, x squared plus 4x, and we're going to substitute 3 everywhere we see an x. So we have 3 squared plus 4 times 3. So that gives us 9 plus 12, which is 21. Okay, let's look at the next example. So we're given the same two functions. This time we're asked to subtract the two functions and then evaluate the new function. So again, this notation can be written as f of x minus g of x. Be careful of the order here. Okay, f comes first in this subtraction, so I want to make sure I rewrite it as f of x coming first. So again, we're going to substitute 2x plus 1 in for f of x, and x squared plus 2x minus 1 for g of x. Now these parentheses are important in this case. Because I'm subtracting, I have to make sure that I subtract every single one of these terms. We could think of that as distributing the negative sign. So we have 2x plus 1 minus x squared minus 2x plus 1. And now I'm going to combine like terms the way I did before. So we have negative x squared, we have 2x minus 2x, those get canceled out. We have 1 plus 1, which is 2. So here we have our difference function. And now we're going to find, f minus g of 2. So everywhere we see an x, we're going to substitute 2. So that's negative 2 squared plus 2. So this is, I'm going to follow the order of operations here. This is 2 squared, which is 4, but we do have that negative sign out front. Negative 4 plus 2 is negative 2. Okay, let's look at our third example. Okay, here we have a product of two functions. Given f of x is equal to x squared and g of x is equal to x minus 3, find f times g of x, then evaluate the new function. So that's the same thing as saying f of x times g of x. And I'm going to substitute my functions in, so that's x squared times x minus 3. So now I'm going to multiply these two functions together, so I have to distribute this x squared. And there's my product function. And now I'm going to evaluate when x is 4. So I use my new function. Everywhere I see an x, I'm going to stick a 4. So that's 4 cubed minus 3 times 4 squared. following the order of operations, going to evaluate those exponents first. So that's 4 cubed, so that's 4 times 4 is 16 times 4, that gives me 64. Minus 3 times 4 squared, which is 16. I'm going to keep those parentheses there to show that I still need to multiply. 3 times 16 is 48. And then 64, take away 48 is 16. Okay, now, part D. So we're given two different functions. F of x is equal to the square root of x, and g of x is equal to the square root of 4 minus x. Find f divided by g of x. Then find the domain of the new function. Okay, so we're not evaluating the new function, we're finding the domain. So, f of x divided by g of x is equal to square root of x divided by square root of 4 minus x. So here, this is our function, okay? It's quite ugly, but this is our function. We could rewrite this as the square roots of x divided by 4 minus x. We're able to do that using properties of exponents. And now we're asked to find the domain. So the domain for all of these functions for part A, part B, and part C, okay, our sum of two functions, our difference of two functions, and our product of two functions, the domain is simply the x values that are common to both domains that are being combined. So if, say, in part A, our domain of the first function, 2x plus 1, our domain was all real numbers. Our domain was all real numbers. In g of x, our domain is all real numbers. So the domain of this function here that we found is going to be all real numbers. And that's what the fancy R means right there. So the same is going to be true in part B because we're using the same two functions. So the domain in part B was all real numbers. In part C, again, the domain of f of x is all real numbers. The domain of g of x is all real numbers. So the domain of this product function is going to be all real numbers. Now, part D, because we're dividing, we have to look for restrictions. So if we take a look at, we'll look at this step. I actually think it might be a little bit easier. It doesn't really matter. We'll look at the final step since that's where I left off. So we have a fraction inside a radical. So we have to make sure that the denominator does not equal 0, right? We cannot have a 0 in a denominator. So that means 4 minus x cannot equal 0. So I need to solve this statement and find out, well, what value of x does make the denominator 0? Well, if I add x to both sides, I get this. So that means x cannot be 4. So we have to make sure that we take that into account. In addition to that, we have a couple of square roots that we sort of have to think through a little bit. So we know that when we're taking square roots, that inside the radical cannot be negative. So we have the square root of x. We know right here that our domain for the square root of x, our domain has to be greater than or equal to 0. And our domain for 4 minus x has to be greater than or equal to 0. So let me solve this statement. If I add x to both sides, I get 4 is greater than or equal to x. I'm just going to rewrite that so x is on the left. So my domain for the square root of x is greater than or equal to 0. Let's put that on a number line, because this is going to get us a little confused here. So that's my domain for the square root of x. For the square root of 4 minus x, I have x is less than or equal to 4. Now, our domain is supposed to be, our domain for our combination function, so this function right here or this function right here, has to be x values that are common to both domains. So if we look on a number line, we could see what's in common, everything from 0 to 4. So all of these values right here are common to both. However, we found a further restriction because when we divided the two functions, we ended up with a fraction. And our fraction could not have a denominator of 0. So now this domain has to be amended. X cannot equal 4. So now I need an open point at 4. So my final domain is all values from 0 to 4, not including 4. So I would write that domain as such. Bracket 0, comma 4, parenthesis. And this is the domain of our quotient function.